Now let us see the direction of kinetic friction. Remember, direction of kinetic friction always remains in a direction which opposes relative motion. The figure shows 5 blocks A, B, C, D and E whose velocities are given with respect to ground. All the surfaces are rough. The block E is moving with velocity 2 meter per second. Block D is moving with velocity 1 meter per second. Block C is moving with velocity 3 meter per second. And block B is moving with velocity 5 meter per second. Block B, C, D and E are moving in rightward direction, while velocity of block A is 5 meter per second in leftward direction. All the velocities shown in the figure are with respect to ground. Now we have to mark the direction of kinetic friction acting between various blocks. As I have already told you that the direction of kinetic friction always remains so that it opposes the change in relative motion. Since block E is moving with velocity 2 meter per second and block D is moving with velocity 1 meter per second, so the block E will have tendency to increase the speed of block D and block D will have a tendency to decrease the speed of block E. So the frictional force acting on block E due to block D will be in leftward direction, that is being shown as FED, frictional force on E due to D, because D will oppose the motion of block E. Similarly, frictional force on D due to block of E will act in rightward direction, because block E will have a tendency to increase the speed of block D. So frictional force on D due to E will act in rightward direction. Similarly, if we look at the figure of block C and D, we observe that block D is moving rightward with velocity 1 meter per second and block C is moving rightward with velocity 3 meter per second. So block D will have a tendency to stop, or that is to decrease the speed of C, and block C will have a tendency to increase the speed of block D. So frictional force on D due to C will act in rightward direction, indicated as frictional force on D due to C, while frictional force on C due to D will act in leftward direction as FCD. Similarly, if we look at the case of block B and C, block C is moving rightward with velocity 3 meter per second and block B is moving rightward with velocity 5 meter per second. So block C will have a tendency to retard the motion of block B, and block B will have a tendency to increase the speed of block C. So frictional force on block C due to block B will act in rightward direction, while frictional force on B due to C will act in leftward direction. If we look at the block B and block A, since block B is moving rightward with velocity 5 meter per second and block A is moving leftward with velocity 5 meter per second, so relative velocity of block B with respect to block A is 10 meter per second rightward, and relative velocity of block A with respect to block B is 10 meter per second leftward. Since block B is moving rightward with respect to block A, So block A will have a tendency to decrease the speed of block B. Block A will have a tendency to decrease the speed of block B. So frictional force on B due to A will act in leftward direction indicated as FBA, and similarly frictional force on A due to B will act in rightward direction indicated as FAB. Similarly, since block A is moving leftward with velocity 5 meter per second with respect to ground, so frictional force by ground on block A will act in rightward direction. Similarly, frictional force on ground due to block A will act in leftward direction. Because ground is at rest, frictional force on A due to ground is in rightward direction, so frictional force on ground due to A will be in leftward direction. So this is how we mark the direction of kinetic friction.